Okay, question is, without using any inbuilt Laplace transform function in Mathematica, find the Laplace transform of e to the power t sine hyperbolic t by integration. So our function is, so let's define this function. Okay, so maybe I define this function as a function of t by this expression, function of t is equal to e power t, so that means exponent of t times sine hyperbolic of t, sine hyperbolic of t, sine hyperbolic of t. Okay, so execute it. So then let's check. So we will put f of t, so it will be this, so 1 over 2 e power t minus e power minus t and plus e power t. So this is the exponential form of sine hyperbolic t. If you don't get this exponential form of sine hyperbolic t, then you may even provide its definition by yourself as well. Okay, so for the Laplace transform, we need a multiplication function. We call that function as kernel. Okay, so we define kernel as exponent of minus s times t. Okay, so it will be minus e power st, and the Laplace of this function will be Laplace of this function of t will be then equal to the integrate the function. Function is now kernel times f of t. This is the function. Okay, kernel times f of t, and then we need to define the integration limits. So the integration limits are in terms of t from 0 to infinity. Infinity, we can write full word infinity starting with capital I, infinity. Then curly bracket close, and then the square bracket close. Shift enter, and then we will get this expression. So it says that it is a conditional expression. The real value of s should be greater than 2. It is valid for those conditions, and the value of the Laplace transform of e power a t times sine hyperbolic of t is 1 over s into s minus 2, and this is correct. So we can even verify it by simple hand calculations as well. So this is in a way where we can just by integration can find the Laplace transform.